Have you ever pondered the possibilities of what might transpire if we were to land on Jupiter? This isn't just a question of science fiction, but a genuine query that has puzzled astronomers and space enthusiasts alike for decades. Planet Jupiter, the behemoth of our solar system, has long been a subject of fascination, an enigma wrapped in the swirling hues of its thick atmosphere. Space exploration has always been about pushing boundaries, about venturing into the unknown and the unexplored. And yet Jupiter remains a world shrouded in mystery, a tantalizing target of exploration that defies our understanding. Our knowledge of this gas giant is still in its infancy, a mere drop in the ocean of cosmic wonder that surrounds us. But what if we dared to dream? What if we dared to land on Jupiter? The implications would be profound, the challenges immense. Now let's delve into the intricacies of Jupiter, and why a landing there would be no ordinary feat. Jupiter's atmosphere is nothing like our own, and that's the first hurdle we'd face. This colossal planet, Jupiter, is enveloped in an atmosphere comprising mostly hydrogen and helium, much like the Sun. But it's not just these gases that make up this giant's atmosphere. Methane, water vapor, ammonia, and even neon are present, creating a cocktail of elements that are hostile to life as we know it. Akin to stirring a pot of molten metal, immense storms rage within this gaseous mix. The most renowned among them is the Great Red Spot, a storm larger than Earth itself that has been churning for at least 3 centuries. With wind speeds reaching 400 miles per hour, these storms would make any hurricane on Earth seem like a mere breeze. But it's not just the ferocious storms that would pose a problem. There's also the small matter of Jupiter's lack of a solid surface. Yes, you heard right. Jupiter is a gas giant. Its atmosphere just gets denser and denser the deeper you go, until it slowly transitions into a sea of metallic hydrogen due to the extreme pressure. So where would we land? That's a question without an answer. The conditions of Jupiter's atmosphere would wreak havoc on any landing attempt. The fierce storms would tear apart a spacecraft long before it could reach the deeper layers of the atmosphere. Even if a spacecraft could somehow withstand these storms, the increasing pressure and temperature as it descends would eventually crush and melt it. And let's not forget the intense radiation. Jupiter's magnetic field traps high-energy particles, creating radiation belts that would quickly fry any onboard electronics, not to mention any ill-fated astronaut aboard. As you can see, Jupiter's atmosphere alone presents monumental challenges, but that's not all. Jupiter's gravity is a force to be reckoned with. This celestial giant, the largest planet in our solar system, packs quite a gravitational punch. Its gravitational force is more than 2.5 times that of Earth. Imagine that for a moment. If you weigh 70 kilograms on Earth, you would weigh a staggering 175 kilograms on Jupiter. That's like carrying 2 of your own body weight on your shoulders every single second. This immense gravitational pull isn't just a problem for any person unlucky enough to set foot on the planet. It presents a significant challenge for spacecraft as well. Launching from Earth is already a monumental task, demanding immense amounts of energy to escape our planet's gravitational grip. To break free from Jupiter's gravitational clutches, that's a whole new ballgame. But let's say we manage to get a spacecraft to Jupiter. The next challenge is landing. The force of Jupiter's gravity would accelerate a spacecraft to such high speeds during descent that slowing down enough to land safely would require tremendous amounts of fuel. It's like trying to stop a freight train with a bicycle brake. And then there's the human body. Our bodies are fine-tuned for life in Earth's gravity. In Jupiter's intense gravity, our bones and muscles would struggle under the increased weight. Our hearts would have to work overtime, pumping blood against a much greater gravitational pull. Over time, this could lead to serious health problems. Of course, these are just the physical challenges. There are also psychological effects to consider. The constant feeling of being weighed down could lead to mental health issues such as depression and anxiety. So if you're planning a trip to Jupiter, you might want to reconsider. The challenges posed by Jupiter's gravity are formidable. It's not just about getting there, it's about surviving once you've arrived. The gravity of Jupiter isn't something to take lightly, literally, and yet there's more. Jupiter's magnetic field is not just strong, it's the strongest in the solar system. A colossal force that dwarfs even the Sun's magnetic field, Jupiter's magnetosphere is a realm of magnetic madness that extends over 2 million miles out into space. It's so vast that if we could see it from Earth, it would appear to be about 5 times the size of our full moon. This magnetic field is not just a spectacle of space, it plays a vital role in creating Jupiter's extreme environment. You see, this magnetic field, like a celestial siren, lures in high-energy particles from the solar wind. These particles are then trapped within the magnetosphere, creating intense radiation belts around the planet. Imagine, if you will, a lethal, invisible force field surrounding the planet, relentlessly bombarding anything within its grasp with deadly radiation. This is the reality of Jupiter's magnetic field, and it's not just a danger to life as we know it. Even our most advanced spacecraft electronics would struggle to survive within this radiation-filled nightmare. Jupiter's magnetic field is so powerful, it even has an effect on the planet's appearance. The auroras we see at the poles are a direct result of this magnetic activity. When the trapped particles collide with Jupiter's atmosphere, they create a light show that would make even our northern lights pale in comparison. But don't let the beauty fool you. These same particles that create the mesmerizing light show also contribute to the production of extremely high levels of radiation. In fact, the radiation levels are so high that they would be instantly lethal to a human and could cause serious damage to the electronic systems of a spacecraft. In the grand scheme of things, Jupiter's magnetic field is a double-edged sword. On one hand, it's a testament to the planet's raw power and a beautiful spectacle to behold. On the other hand, it's a deadly force that presents a significant hurdle for any potential missions to the planet. So the magnetic field of Jupiter adds another layer of complexity to the idea of landing there. It's yet another challenge we would need to overcome in our quest to explore the vast, wild frontiers of our solar system. So what does all this mean for our hypothetical landing on Jupiter? Let's take a moment to reflect on the colossal challenges we've discussed. The first hurdle, Jupiter's inhospitable atmosphere, is a swirling tempest of clouds, storms and gases, unlike anything we have on Earth. It's a maelstrom of mysteries, where jet streams whip around at tremendous speeds and the legendary Great Red Spot rages on, a storm larger than our home planet itself. Overcoming this atmospheric chaos would require a spacecraft capable of withstanding extreme turbulence, unpredictable wind patterns, and corrosive gases. Not to mention, this craft would need to endure the immense heat and pressure that increase dramatically as we descend into the Jovian atmosphere. It's a tall order, to say the least. Then we have Jupiter's crushing gravity, over 2.5 times stronger than Earth's. Imagine a weight suddenly tripling on your shoulders. That's what a spacecraft would experience, except on a much greater scale. To stand a chance against this gravitational grip, our technology would need to evolve significantly. We're talking about the kind of leap that took us from the Wright brothers' first flight to landing on the moon, but compounded many times over. Finally, there's Jupiter's lethal magnetic field, the strongest of any planet in our solar system. This invisible force field traps high-energy particles and creates intense radiation belts around the planet. To venture into this magnetic madness and come out unscathed, we'd need to make monumental strides in radiation shielding technology. So, the question isn't simply can we land on Jupiter, but rather, how can we possibly equip ourselves to survive the journey? It's clear that landing on Jupiter would necessitate technological advances that, at the moment, are purely speculative. It's a tantalizing thought experiment, a challenge that might inspire future generations to push the boundaries of what's possible. Landing on Jupiter isn't just a giant leap for mankind, it's a leap into the unknown, and it's far beyond our current reach. So, we've learned that a landing on Jupiter is currently beyond our reach. But what does that mean for the future? It means that we continue to strive, to explore, to push the boundaries of our knowledge and capabilities. The cosmos, with its myriad of celestial bodies, remains a vast and mysterious expanse, waiting to be understood in all its complexity. Jupiter, the gas giant, with its tumultuous atmosphere and intense gravitational pull, presents a compelling challenge. We might not be sending humans to Jupiter just yet, but that doesn't mean we are abandoning our quest. Unmanned missions, robotic explorers, could prove to be invaluable tools in our pursuit of understanding. These intrepid machines can venture where humans can't, gathering crucial data, unlocking secrets and bringing us one step closer to unraveling the mysteries of our solar system. While we may not be landing on Jupiter anytime soon, the journey to understand this giant planet is far from over.